Today we are going to do section 3.3, rate of change. Okay, now what is the rate of change? First, let's look at the symbols. Okay, this is called the triangle is called delta. Delta y is means is one symbol together. Okay, it's like Mr. Smith, two words, one guy. So delta y is one symbol. It means the change of y. That is, you subtract y2 by y1. y2 minus y1 equals to delta y. Similarly, delta x, one symbol, okay, like Mr. Jones. So delta x means has a specific meaning. It means x2 minus x1. That is the change in x. X used to be at x1 and now it got to x2. So the change is called, when you subtract, is called delta x. Similarly, y used to be at y1 and now it got to y2. So the change is then delta y. As you notice that delta y or delta x can both be either positive or negative. Now this y2 at this point, y2 also means f of x2. Okay, that is and y1 is also called f of x1. These are all the same things. Now, you might remember from the previous chapter that y2 minus y1 over x2 minus x1 equals to m, which is the slope of a graph. But we're not going to care about that right now. Okay, that is true. But right now, we're only going to focus on this part. That is the delta y over delta x, which is the change of y over the change of x, is calculated by the y2 minus y1 over x2 minus x1. So having said that, let's do that. Okay, turn the page to wherever the next page is. Let's look at example 1. Example 1, we are supposed to do what? Table 1, where is that? Is that the previous page? All right, well, the table we have to do, to do example 1, we have to look at the previous page and calculate the rate of change of price of gasoline between 2007 and 2009. So that is, so the gasoline, and so our change we'll calculate is the cost of gasoline, okay, divided by the difference of year. We'll call it delta of year. So what's the difference in year is, so what are we doing? It's 2007 and 2009. So x2 will be 2009 minus x1 is 2007. So that's the year change, okay? And then the gas change, and we'll go back to the page and see what the prices are. 2008, 2.41. Okay, that's, no, that's the final, right? Well, what did we want? 2007, not 2008. What am I talking about? Okay, 2007 is 2.84. That's the first price. So we'll write it over here, 2007, yes. 2.84, that's the price of gas, okay. And then later, 2009, our price is at 2.41. Okay, do the subtraction, and whatever this thing comes out to be, that would be our change of gas compared to the change of the year. As you can notice, apparently the gas price went cheaper. So so please do this, okay, yourself. Use the calculator to calculate this thing. I am. Let's see. All right. So well, I guess we can just do this, but in our head. So that equals to 84, and that's negative 43 cents. Okay, 0.43, and divided by 2 years, and that would be about negative 0.222 if we round it up, and that's the answer of the rate of change. So next, that's example 1. Please do that by yourself as well. And next, let's look at example 2. What do they want? Okay, let's look at the rate of change from 1 to 2. Okay. So this is example 2 on the later page. As you can see, from 1 to 2, the y value changes by only 1, because at 1 is 0 and at 2 is 1. So the delta y equal to 1, and so is delta x. So the change should be just 1. Let's see, unless, oh, sorry, it's from minus 1 to 2. So it's not so simple, is it? Okay, let's look at what happens at minus 1. At minus 1, the value looks to me like 4. Okay, so the values to change at from minus 1 to 2. So then let's write down this. Okay, so delta x is there's delta y. Okay, equal to, and the first x value x1 is minus 1. Okay, and the second x value is 2. So we have 2 minus 1. That's the y value. And then the x value, the first x value looks to me to be like 4. And the second x value and the second y value is at, what did I say it was? 2, right? Yeah, it's at 1. Right? So that should be it. And then if we do the math here, that would be minus 3 over 3. So that equal to negative 1. And that should be the answer. Yep, it is. Okay, so that's example 2. Please do that as a part of your homework as well. Now the example 3, after picking up a friend who lives 10 miles away and leaving on a trip, Anna records her distance from home over time. Average speed over 6 hours. Well, whatever. So let's look at the problem. The average speed is, what are we asking? I don't know what this problem is asking. Oh, find her average speed over the first 6 hours. So what are the first 6 hours? Okay, that's hours 1, 2, 3, 4, 5, 6. And then we'll start counting at let's see. We'll start counting at, okay, from 6 to 10. Okay, so we've got to figure out what are the first 6 hours. So we'll count it from 0 to 6. So again, we will calculate delta y over delta x. So delta x will start at 0, position 0, and then end it at hour 6. Okay, so delta x is 6 minus 0, and delta y will start at 290. We'll end at 292. Okay, and then the starting point is at 10. So then, so all said and told, that's it. And we'll write, I guess we'll calculate what that is. That becomes 282 over 6, and that equals whatever. I suppose we can even do the math. 6, that's 4, 24, 42 divided by 6. Isn't that 7 or something? Yeah, it is 7. What was I thinking? Okay, so it's 7, so that is that. So basically, what we're doing here is calculating the change of time, okay, and then the change of distance, and just come up with a fraction. So all we're doing here is doing one fraction. And then, so next, let's look at example 4. We're now on page 226. And we'll do problem example 4. It says that compute average rate of change for on the interval 2 and 4. All right, so we have a function. So for the interval 2 and 4, we need to figure out what it is. So then first, let's calculate what the values are. So when x equal to 2, what is f? F is x squared minus 1 over x. Okay, I should probably write that down. So x squared minus 1 over x. So if x is 2, then f is equal to 2 squared minus 1 over 2. That's 4 minus 1 over 2. That is 3.5. Okay, and then so this is f of x is equal to 3.5 if x equal to 2. What was the other thing? 4. Okay, if x equal to 4. Then f of x equals, so put 4 in here, that's 16 minus a quarter, that's 15 3/4. All right, so now we got that, and we have to stick it in this relationship. Okay, so again, well, delta y, which is the change of f of x, okay, because y is f of x. And anyway, so I should write that down. F of x equal to y. okay? Or y equal to f of x, either way. So anyway, delta y against delta x is, let's divide the y value, which is, x is going from 2 to 4, so we have 4 minus 2, and y is going from 15 and a quarter, 3/4, I mean, subtract, starting at 3.5, if I didn't get the math wrong, okay? Okay, so then now we just have to do this bit of fraction, which you can use your fractional calculator to do, or do it in your head, either way. And that's 12 and 1/4, I think, divided by 2. That would be equal to 6 and 1/8. Okay, divide each chunk. 12 divided by 2 is 6, and then 1/4 divided by 2 is 1/8, and that should be the answer. Yep, and the book says the answer is 49, right, over 8, which is what that is. So we're good. And so that is that. And next, let's look at example 5. So please do example 4 as part of your homework. And we're just, in this section, it doesn't seem like we're doing a whole lot of interesting things. We're just doing the exact same thing. It's called the rate of change. And so, well, we will do that, okay? And so let's look at example 5, where it says some force can be the distance by the, well, some force is calculated by some formula, okay? We don't need to know the details. If the distance goes from 2 to 6, so the formula says F, example 5, F equal to 2 over d squared. Okay, and d is changing from 2 to 6. So d is changing 2 to 6. Okay, so then we have to calculate. What we are doing is delta f divided by delta d, which is not different from what we've been doing. Okay, just a different of name. So then d is now the new x, and then f is the new y. But we're going to do it the same way. So d changes from 2, okay, to 6. So we have 6 minus 2 as the delta d. And delta f, we plug 2 in here, that's 1/2, okay? If you plug 2 in there. And if you plug 6 in there, that is 1 over 636. That will be 18. And we'll do the subtraction, something like that. And then now it's just a matter of doing fractions. And so what's 118 minus 1/2? That's equal to 9, and that's 9 over 18, okay? And subtracted by 1, that's negative 8 over 18. And then divided by 6 minus 2 is 4. Now notice how this I'm doing this fraction, okay? Because to divide by a number is the same as multiplying by the fraction of this number. So this is the numerator, okay? And then when you do the division, when dividing by 4 right here is the same as multiplying by 1/4. Now please make sure that you know how to do this, all right? And if you have a problem, then I think you should review some parts of chapter 1 or some other place where fraction division is carefully explained. So anyway, so we got this thing, and that should be equal to, let's cancel something out. 8 cancel with 4 is 2, so that is minus 2 divided by 18. Oh, I forgot to cancel out the 18. Okay, so that's minus 1 over 9, and that should be the answer. Okay, if I didn't mess up. There's quite a bit of fractions here, so I tend to mess up, which in this case I didn't. All right, so that is example 5. Now let me clean off the board. Okay, next let's look at example 6 on page 227. We have what we're doing, more rate of change. Okay, now we have some function which says g of t. I'll write it down here. G of t equals to t squared plus 3t. And then and my marker is acting weird. 3t and then plus 1. All right, and the interval is we're changing from 0 to a. Okay, 0 to a, And so we are going to do the rate of change. So we'll follow the same formula. Instead, now we'll call it delta G, I guess. Good enough for me. And then the other one will be called delta T. So then delta T is going to be equal to A minus 0. And that's the easy part, okay, because it goes from 0 to A. So it goes, so it's A minus 0. What about G of, what's that? That we will plug it the same way. G of A, we'll plug A right in here, okay? That's the final result. So plug A in here, we get A squared plus 3A, and then plus 1 minus, and then we'll plug 0 in here. If you plug 0 in here, you only got the 1 left, okay? Because all the t's become 0. So that is delta G over delta T. And then at this point, we'll just do some algebra, okay, and see if anything come of it. So we have, that's a plus 1 minus 1, that part goes to 0. So we have just A squared plus 3A and divided by A, which as you can see, there are lots of A's here, so it's good for canceling. So we'll cancel out the A at the bottom, and so then that gives us A plus 3, and that should be the answer. So the rate of change is A plus 3 for that, whatever that is. All right. Okay, so let's go look at the next thing. Now, example 7, no, not example 7, just let's look at the next page, okay? Now, the rate of change is when is, and well, a function is increasing or decreasing or staying level, okay? And we have, consider, for example, this wavy function. As this part is increasing, it goes all the way to the top, and then it went down, so that part is decreasing, and then it went up and increased again. So that is that's all we need to say about that. Now, also, there are some things that should be mentioned, is that when functions are going up and down like that, then you have something called the local maximum or local minimum. That is, for example, that point right there, at the mountaintop, the little mountaintop, that is a local maximum. It's called local because it's the maximum in its immediate area. Everything around it is less than it. So it's that's why it's called local. It's locally the king of the hill. Now, if you look a long ways away, somebody else might be taller than it. But in the meantime, everything around this guy is shorter than it. Okay, so in the guy's immediate neighborhood, he is at the very, very top. And similarly, this is called the local minimum. Okay, and that is around this immediate area. Everything else is this is the lowest point. Okay, everything else is taller. There might be lower points in some other place, like this graph keeps going down, but we don't care about that when it comes to local stuff. Okay, local stuff, we focus only on this immediate area. So that's what the local maximum or local minimum means. So let's turn the page. What's that? And then there are some facts that we want to mention. That is, if you have a local maximum, okay, the only way you can have a local maximum is if the function starts out being increasing and then end up being, and then got to the maximum and start doing decreasing. That will create a local maximum. And for the local minimum, it's the same way. If you have a local minimum, you know, it looks like this, the upside down of the local maximum, then the function has to be decreasing first, reach the minimum, and then crawl up again. And for at least in this small area that we are talking about, it might do something else in a long ways away. But for the locals, that would be the situation. And then, so having said that, let's consider example 7. It says, identify intervals on which the function appears to be increasing. All right, well, that should be easy enough. And that let's stare at this thing for a bit. Okay, so the function starts from below 0, where it's going down, because we're walking this way. Okay, so if we are walking this way, what am I talking about? No, we're not. We're walking the positive. Am I pointing? Why am I pointing with that hand? Okay, this hand, that's better. We're walking from negative x to positive x. So you're standing up here and you're going that direction. So you're going down, right? So that's decreasing all the way down until you reach x equal to 1. So you're at local minimum. And then from that point, you walk up, up, up. and got here, and so you reach a local maximum, so then you walk down a little bit again, another minimum, and then you walk up again. So the function increases and decreases several times in this example. And that is that's that. Next, let's look at example 8. Now we're on page 230 of 230, example 8. Okay, and we have local extrema from a graph. All right, if we're just going to stare at the graph, what's the local maximum? Well, there's something that has a low point and a high point. Well, this problem actually asks you to use the calculator to do that, which is okay. If you plug it into a calculator, such as the Desmos graphics calculator, it will, as you move things around, you can actually locate the absolute minimum point, which, yeah, well, anyway, so that's all. I'm not gonna go too much into this problem. It's just a matter of moving dots around. Okay, if you plot this into the Desmos calculator, let's say, and you move your cursor around until you get to the point that looks about the maximum, the other one looks like at the minimum, and that is yeah, that. So let's move on. Let's see, next let's look at example 9, which has a far better view of things. Okay, this is a much clearer graph, and you don't need a calculator for this problem either. So let's look at this thing. We have what is that? That's a minimum there, right? And it seems to be x equal to -1 and y is -2. That's a local minimum. On the other side, at x equal to 1, you notice there's a local maximum there at 2, and so that is the answer. Okay, so look, yeah. Okay, so the local minimum at x minus 1 is, and then local, yeah, well, x equal to -1 and is -2, and then of course local maximum is x equal to 1, and y value is 2, and that is the maximum value. All right, so that's that. Now, okay, now let's look below the page 231 and look at all the toolkits problems. The reason they're called toolkits is because we see them a lot in homework, and so we will talk about them briefly so that you become familiar with these problems, which will make homework going much faster. Okay, so there is so for example, there's f of x equal to c, the constant function. Okay, identity function where f of x equal to x, that's increasing. Well, that doesn't go anywhere, right? Because it's just constant, it's on level. And so the identity function is increasing. The quadratic function falls down first, and then go back up later if you're walking, let's see, this way, okay, and into the positive direction. And well, these are all actually quite obvious. So please look at the rest of the graph by yourself on page 232, just to take a quick look at them, and also to memorize what they look like. So, because it's good for you to see the word, for example, f of x, which is y, equal to x cubed, then your brain immediately remember what the x cubed graph looks like, something like that. It goes down and then crawl up and goes level a little bit, that kind of thing. So please look at these graphs yourself, and then I will and I will go to the next page. Now let's look at page 233, where we talk about the absolute maximum and the absolute minimum. So far, we've only talked about the local maximum and the local minimum. What's the absolute one? Just means that what is the biggest one of the graph, okay, regardless of whether it's local or not. For example, let's look at this thing on page 233. As you can see, this graph stops at both ends, okay? It doesn't just keep going forever. If it keeps going forever, we'd have arrows there to indicate. But the dots means the graph stopped right there. In that case, then the absolute maximum is exactly where it reaches on the other side, where f of 2 equal to 2. That's the maximum. And the absolute minimum, however, is also the local minimum, because that is the lowest point of this thing. And it is at 0, where the value is at -2. So the difference between absolute and local just means local considered a small area, and where things are all, where something is at the maximum or the minimum compared to this immediate area, whereas maximum, the absolute ones are just asking you, well, what's the biggest this thing or smallest this thing can get. And so let's look at example 10, where we have the absolute maximum and minimum from a graph. So you can see that very quickly. The maximum, the absolute maximum is definitely at 16, where it reached there twice, okay? And the absolute minimum is that thing down there is about -10, I'd say. So that should be it, right? 16 and -10, yep, that's it. So let's move on to, this is it, okay? So for homework, please do, okay, so for homework, please do, where is it? Okay, 3.3, which is on page 234. For homework, please do problems 5, 9, 11, 17, 19, 21, 23, 25, 27, 29, 31, and 45. Now, most of these homework are actually quite short, so it shouldn't take you as long as some of the other homework section. So when you're done, please come back, and I want to talk about some of them. So now that you're done with your homework, let's talk about some of them. The a of t, okay, problem 11 says a of t is 1 over t plus 4, and t changes from 9 to 9 plus h. Okay, so we'll do that following the rate of change formula, which is, the result is delta a, okay, over delta t. And that would be equal to, first on the bottom is 9 plus h, the final is 9 plus h, minus the initial, which is 9, okay? And then the top, we'll plug it in, okay? So we have 1 over 9 plus h, that's the final result, minus 1 over 9 plus 4. And that, once we get this fraction to come out, then we will get the answer. Now this looks kind of like stuff we did in chapter 1, and it is, okay? And so we'll use the skills we learned in chapter 1 to get this thing to look more decent than this, okay? But if you don't remember how to do this, I think this is the last section of chapter 1. Please review that section until you're familiar with how to manage handling fraction. They're called rational expressions or something like that. Anyway, so let's do this. Okay, so on the bottom we have 9 minus 9, so we only have h left. That is a plus. And on the top we have, so we have 1 over 9 plus h, and then minus 1 over 13. So what we're going to do is this h, I'll write it as a fraction on the side, so that this whole thing becomes, so this is written down here as with a common denominator of 9 plus h and 13. Okay, and then so that will, so the first part then becomes, let's see, so the first part is 13, okay, because if you cancel out, it becomes this thing. And then subtracted by the second part is, there's also this thing here, 9 plus h times 13. And then the second part, then we'll have 9 plus h on here, because when you cancel it out, you see, if you cancel this out, it becomes 1 over 13 again. So it must be correct. So remember that this part, this dividing by h is the same as multiplying 1 over h, which is why I have it written here. So that now that we have that, okay, and then this is 13 minus 9 plus h. What is 13 minus 9 plus h? I'll write it here, 13 minus 9 plus h, and notice that 9 plus h is in parentheses. Even though I don't have it right here, in reality it's in parentheses because I was subtracting by this whole chunk, okay? And then so that would become, that's equal to 4 minus h. That is the entire numerator. So this deal becomes 1 over h, okay, and times 4 minus h, and then 9 plus h times 13, and that seems to be about it. Okay, let me see what the answer says. The answer is different from what I have, so let me check to see if I made a mistake. Okay, I found my mistake. See, we're supposed to plug in 9 plus h in here for t, right? So I have, well, what happened to the plus 4? I forgot the plus 4. So that changes things a bit. That means, so there's a 4 here. So instead of the 9 plus h, this should read 13 plus h. That's much better. Okay, so this is actually 13 plus h, and that changes things. I got to figure out, so if it's 13 plus h, so then the thing here would become, instead of 9, it should say 13 plus h, okay, to be the common factor. So that's 13 plus h, and that's 13 plus h. Okay, so let's write that out. And then the stuff on top might also change. I think that is 13, so that cancels to be 13 plus h. And this should say 13 plus h on top. All right, so here is 13, okay? And then that's 13, that becomes 13 minus 13 plus h, so we have only an h on top. Yeah. So there is none of this stuff. And that is 13, okay? And so that is becomes just h, okay? That's 13 plus h, and then the h cancels out. Okay, so then, and that, which is much better, okay? I always love things when they cancel out. So then we get, so then it becomes 13 times 13 plus h. I write the 13 in front for no reason, and that's just how we normally write things. So that should be the answer. Yeah, that is the answer, except I have a -1. Oh yeah, there's, see, it's a minus h. See, the minus applied to both things, so this is actually a -h. Better not forget that, otherwise the answer is still wrong. Okay, very close, but very far away. So then, so that is actually is the correct answer. All right, so that's problem 11. So next, let's look at problem 17, where we have the average rate of change from x equal to 2 to x equal to 5. So, so 2 to 5, that's delta x. So let's write that down first. So delta y and delta x. So what is delta x? My board is a bit wet. Okay. So it says that x, we want x to go from 2 to 5. So it's 5 minus 2, okay? Final minus initial. And then what is delta y from 2 to 5? We are going to calculate what is the value at 2. At 2, the value from the graph, as you look at it, okay? At 2, the value is 3, right? Yeah. And then at 5, the value is 7. So it goes from 5 to 7. The fact that it wiggled much more in the middle, we don't actually care about that. We only care about these two things. And so the final result, that is. Okay, so then the solution then should be equal to 7 minus 5. That is 2 on top and 5 minus 2 on the bottom. So 2/3. Let me see. Well, the book says 4/3. Did I get it right? Get it wrong? 7 minus 3. Because isn't that what I said? Yeah, the value of 2 is at 3. Why did I say 5? I think I was confusing it with this 5. The value at 2 is 3, okay? And the value at 5 is 7. So 7 minus 3 is 4. That's true. So 4/3 is the correct answer. Let me double check problem 17. Yep, that is. So that is that. Now next, let's look at problem 31. So let's turn and find 31. Where is it? I see something here. Okay. So problem 31, we're supposed to find delta y over delta x again. All right. So let's do that. So problem 31, we have, let's see, what's the function? G of x equals to 3x cubed minus 1. Doesn't matter what it is. We're just going to do it the same way. Okay, we'll apply the same formula and try not to mess up like I did, and no matter what happens. So the x value changes from -3 to 3. And therefore, we will write down that in this case, we'll do delta y equal to gx, okay, in this case, and then delta x. So delta x goes from 3 to -3. That's a total of 6 units, okay? So we'll write down 3 minus -3. There are two negative signs there, which becomes a plus, but we'll deal with that later. And then we'll plug in 3 for here, which is 3, right. Well, maybe we should just write it down. Okay, so it's 3 times 3 to the power 3, okay, lots of 3's, and then -1, okay, minus the -1, which we will put in parentheses because there's stuff in there. Anyway, so the -1, we'll write down the same thing, which is 3, okay, let's see, -3 to the power 3, too many 3's, and then again -1. So this has to be done very carefully so that we don't mess up a negative sign and get the wrong answer. So let's do that. 3 minus -3, that would be 6. That's the easy part. Now this thing is 27, okay? 3 multiplied by itself 3 times. It's not 3 times 3. It's all, imagine 3 3's multiplied by 3 times 3 is 9. 9 times 3 is 27. And then you still have to times 3. 27 times 3 is 81 or something. Okay, yeah, I think so. And check with your calculator if you're not sure. So anyway, so we have 81 minus 1 minus, and this thing. This is -3 to the power 3 times. So it's negative again. Okay, it's negative, negative, negative becomes negative. And so the whole thing is this, otherwise it's the same value as that. So it's also 81 because it's 3 multiplied by itself a total of 4 times. So that's 81, and then inside that is just -1, so we'll write that down. Okay, and notice that this is in parentheses because we're subtracting by the entire object, which means that what that means is everything in here becomes positive. Okay, when you take out the parentheses, so these become a plus, and okay, so that's 81 plus 81. Continuing, so we have 81 plus 81, and then the -1 and then +1, that does go to 0, and then divided by 6, and that equals to some value. What is that? We can, if we cancel out something, that'll be faster. Okay, so that let's cancel out the 3. That goes back to 27. That's also 27, and that's 2. And so that's 27 plus 2 27s divided by 2. That should be just 27. And of course, you can also use the calculator if you feel more comfortable with that. Let's see, what problem is this again? 31. So let me see if I can find problem 31. 27. Yep, that is the right answer. Okay, so next let's do problem 45. First, let me find it. Okay, for 45 on the following page. Problem 45 is a big long thing that is not saying a whole lot actually, but we'll read it anyway. So problem 45, and we have they started filling up gas at 3:40. Okay, so time T1, we call it time, the first time as T1, we will call it at 3:40. All right, 3:40, and then they started pumping, and then at time 2 at 3:44, they pumped gas for 4 minutes, and the tank was full. And then they pumped 10.7 gallons. Okay, what is the average rate of flow of gas into the gas tank? So in this time, they pumped a total of 10.7 gallons. All right, so then so the change of gasoline, which is delta Y, is going to be equal to 10.7. Okay, and then the delta X, which is the change of time, we can also call it delta T. Maybe I should call it delta T, which stands for delta X. Okay, and so the change of time, we'll call it delta T, will be equal to this time subtracted by that time, which is 4 minutes. Okay, and so then what are we asking? What is the average rate of flow? Is that asking for per minute? Let me see. Better not be asking. Yeah, I think so. Anyway, so 10.7 divided by 4, whatever that is, that would be the answer to this problem. Yeah, so let me look at that. Yeah, all right. So let's calculate 10.7 divided by 4 with some calculator. Yeah. Let's see. So 10.7, okay? And this is an easy one. So you just punch it in here in my calculator. All I typed in is 10.7 divided by 4. And remember the division line, I mean this line, the fraction line is the same as division line. So then you push equal, and then I got this thing, which it gives me a fraction. I'll push some button that changes it. Okay, there's a fraction conversion button, which in my calculator is this thing right here. But it might be different on your calculator. Please figure out where it is. But anyway, it's 2.67, which we round up to be 2.7, and that is the answer. Okay, and that is, oops, my point is too high, 2.7, and then that should be the end of this section.